All right, let's dive right into this explainer. Today, we're unpacking a piece of tech that is quite literally rewriting the rules of modern warfare, the Kamikaze drone. Specifically, we're going to look under the hood to see exactly how these systems manage to hunt down and strike their targets with such terrifying, calculated precision.
To really wrap our heads around this tech, we first need to get our terminology straight. The actual technical term here is loitering munition. Think of it as a deadly mashup. It perfectly combines the surveillance power of a standard reconnaissance drone with the lethal payload of a precision strike platform. It's expendable, it's unmanned, and crucially, it doesn't just fly from point A to point B, it patrols.
The operational logic here is just totally different. If you think about a traditional weapon, like a cruise missile, that's basically a very fast, very blind runner rushing in a straight line to a set of pre-programmed GPS coordinates. But a kamikaze drone? It's a predator. It stalks its environment, it stays airborne for extended periods, basically hanging out in the sky, watching and waiting for the absolute optimal moment to strike.
But here's the real kicker. The economics. A traditional Tomahawk cruise missile will set a military back, over $1.4 million per round? A tactical loitering munition can cost less than $10,000. It's a fraction of the cost, and that completely shifts the battlefield math. Militaries can now compress the entire kill chain into a single, affordable platform that can be unleashed in massive volumes.
So, here's our flight plan for this explainer. We're going to break down the literal anatomy of a strike, going step by step from launch to impact. We'll hit 1. The hunter-killer drone. 2. Launching and loitering. 3. AI and target acquisition. 4. Navigating without GPS. And finally, 5. The terminal dive. Let's move right into Section 1, the hunter-killer drone. Let's look at the actual hardware we're dealing with here. What's really wild is the sheer variety of tactical options out there right now. These systems scale dramatically. You've got highly portable, sub-1 kilogram models designed for infantry, like the Spike Firefly with a 1 kilometer range that a soldier can literally carry in a backpack. Then, on the other end of the spectrum, you have robust platforms like the Hero 120 or the Lancet 3. Those larger systems pack heavier warheads, can fly for almost an hour, and can hit targets up to 40 kilometers away. The hardware is completely tailored to the mission profile. Okay, Section 2. Launching and loitering. How exactly are these weapons getting into the air to start hunting?
The whole operation typically runs on a highly structured 5-stage cycle. From the second it powers on, it's hardwired to follow this sequence: launch, loiter, target acquisition, terminal dive, and finally, impact.
Looking at those first 2 stages, the deployment is incredibly fast. These things are shot out of portable tubes or pneumatic catapults, which means absolutely no runway infrastructure is needed. A small, dismounted infantry team can set this up rapidly in the middle of nowhere. Almost immediately after launch, the drone enters a holding pattern high above the target zone to wait. A short-range electric system might just hang out up there for 15 to 40 minutes, while the bigger, fuel-powered ones can literally circle for hours. Which brings us to the really crucial part, Section 3, AI and target acquisition. Once it's up there, how does it actually find its mark? This is where the tech feels like something out of a sci-fi movie. While it's circling, the drone is using onboard electro-optical and infrared cameras to constantly scan the ground. It feeds that visual data into advanced AI and machine learning algorithms that autonomously detect and track things that are trying not to be seen, elusive, hidden, or moving targets. It's streaming a live video feedback to the parent unit the whole time. But, and this is super important, it still retains a human in the loop. The AI acts as an incredibly smart spotter doing the heavy lifting, but an actual human operator has to give that final green light to strike. But what happens when things go sideways? Let's look at Section 4, navigating without GPS. On a modern battlefield, GPS signals are basically the first things to get jammed or spoofed by electronic warfare. To overcome that massive blind spot, engineers layer in alternative navigation methods. First up is visual odometry. Basically, the drone looks down with its camera, watches how the environment is moving past, and calculates its location visually. Next, they use controlled reception pattern antennas, CRPAs, which act as a filter to block out severe jamming noise. And finally, for the actual strike, it uses optical terminal guidance. It continuously compares the live feed against stored reference images so it can visually lock on and confirm the target, completely independent of GPS. All of this stalking and tracking culminates right here in Section 5, the terminal dive, the decisive final action. Once the human operator gives the strike approval,
The munition breaks its loiter pattern and drops into a high-speed dive straight toward the target. What makes this phase so devastating is the payload modularity. Depending on the job, you can swap out the warhead. Hitting a building? Pack a high explosive. Going after personnel? Use a frag warhead. Need to punch through thick tank armor? Slot in a shaped charge. Or you could use a thermobaric warhead to create a massive pressure wave inside a bunker. The drone is basically a custom delivery system for whatever effect is required.
But here is the craziest part. Unlike an artillery shell or standard missile, this smart weapon has a wave-off capability. It can literally abort its terminal dive mid-flight. If the target suddenly moves into a crowded civilian area, or if the operator loses positive identification, they can wave off the attack, the drone will pull up, break off the dive, circle back, and wait for new instructions. You just cannot do that with a bullet.
By compressing the ability to patiently hunt, visually track, and precisely destroy a target into one highly affordable AI-driven platform, loitering munitions have fundamentally changed aerial warfare. And that leaves us with one massive question to chew on as we wrap up this explainer. As artificial intelligence gets smarter and autonomous targeting gets even sharper, how is the balance of tactical power going to continue shifting on the modern battlefield?